So today I'm continuing with my Learning Go mission, and today I'm just doing the basics of Go. And right here, if you watch my last videos, I already set up Go, and Emacs is my editor of choice for Go, and I've installed the all these things needed to compile Go programs. So now in Go Work, which is the directory I set up for all my Go programming when I install Go, is in my home directory. I got the bin and source directory, and I already made a hello folder, which is going to correspond to my hello.go program, which I'm doing everything in today. So let's go there. Here's the hello.go program, and it has nothing in it. So the first thing we do for Go program is define the package, and this package is going to be main, because this is where main is, and we're going to import the FMT library, which is the format library. Okay, and now let's do the function. Our first function is going to be main, just like the package. And one note I want to say here is that this is not legal in Go. This is the way I like programming. When I do the formatting I like when I program, I like to put the the curly brace on the next line, but that's illegal in Go, and I'll show you in a minute. Let me just declare a variable. So to declare a variable in Go, you just type var message, and then the type of variable it is, a string. String is a built-in type in Go, and let's set this message equal to something, hello world. Put a new line, and FMT, call the format library, printf, and I want to print this message. Control X S to save it, and let's compile it with go install hello, and run it with go path bin hello, $go path bin hello, and it's hello world. Now let me show you that error. Now I'm gonna put this on the next line like I like programming. Save it again. Let's go try to compile it, and we get some errors here. Specifically unexpected semicolon or new line before the curly bracket, non-declared statement, all kind of things pop up there just from that. So we'll see again that they go away after we change back to the proper Go code formatting. And here we are. Okay, so this is the way to declare a variable. There's also a kind of shortcut way to declare it. So I'm going to comment this out, and comments in here kind of like C. Just do it like that, / star, and then we end it a star, and then another / in reverse order. Okay, so let's declare a message again, but the shortcut way. We're going to say message : equals actually, let's do it on this line. All we have to do is say message : equals hello world, and let's compile that, and it works just like the other code we just did with the var message string. Go is a statically typed language, so that's why we usually you can declare your variables like this, but it also has some like dynamic typing type features, so that's why we can just do this here, and it can kind of pick up the type by inference. So let's go on to the next example. Now that I've done something with strings, let's add a number in here. Just say number is equals 28, and I want to print that out, so I'm just going to put a plus here, and numbers are that's an integer type, so we're going to put this is kind of, if you're familiar with C, this is very common syntax in C, saying that I have a number here, and let's print out that. So we got a decimal number, and then we're going to actually have the number, and so this should compile. And let's run it. Okay, and I forgot to put my new line here, so everything's, and I can actually take my new line off here, so they'll print on the same line, and put a space before the percent sign, and there we go, hello world 28. Okay, and let's keep moving on. What am I gonna do next? Let's see, let's print out 2 messages and a number. So we got hello world here. Let's do a message 2. And say hello Kim. That's me. And I'll probably put everything on a new line this time, since we're printing out more than a couple of things. Okay, message, and print out message 1, and here we print out message 2, and let's see, does this work? I've never tried that out before. Let's see. Yeah, that works. You can say it like this. So you can say message 2, and then this decimal number, and then the actual number, and let's see, does it come out right? No, it didn't. No, it didn't. So probably the best way to do this is to add that, concatenate that string, and then compile it, and we're still not right yet. Let me check to see what I'm doing wrong. Let me read there. That's what I was trying to get to. I'm not sure what I was doing wrong with the syntax before. I'm gonna have to check that out. But this prints it out just fine. Okay, so we got that. Okay, let's scratch all of this and move on to see how do you do a float. You do a float. So let's say pi. So you say var pi float. You got float 64. They also have a float 32, but let's do the float 64 first. 0.14, and then let's just print it out. %F for floating point, and the actual pi. Okay, clear over here. Let's go compile it, and pi is that number, 3.4. If we want to make it such that it goes to just 2 decimal places for significance, I think you can do this. Kind of like in C, I think. Yeah, there it is. Okay, so that's pi. Okay, and for this number, it doesn't matter. You can use float 32 to also. So let's compile that, and we get the same thing. Okay. And you can also just do this like that, 2.2. So it's the same thing. Okay, so now let's keep going on. You can do another integer. Now this is another way to declare. You can say var, you can say var my num is equal to 2. So that's a little different than we did before, where we put var my num and like var pi and float 64. You know, we can just do it this way also. And let's print that out. fmt dot printf my num is %d new line. Okay, let's compile that. My num is 2, so that works. Moving on. Now another type is your Boolean type, and you can say var my Boolean, and we can say fmt dot printf my bool is %t. This is for truth value. My bool. Okay, and compile it. Okay, this is not Boolean, it's just bool, I think. Yeah, that's right. It's just bool, not Boolean. Okay, and let's go on to the next one, and let's see what I'm going to do next. Let's declare bool the other way. So we can say my bool colon equals true. We only have two values, true and false, both lowercase. Go install that, and there it is. So it should be noted that the default value of bool is false. Okay, so can do one more thing. We can say my bool, and we can do we can negate it. We can say not true. Okay, and now it should print false again. There it is. My bool is false. Clear this. And let's go on to some more involved strings. So I'm going to do my string, and I'm going to do one of my strings I write sometimes too. So let's take one of my strings. Okay, let's put okay, and let's do this. This is something I sometimes wonder. Okay, so now we have a string, and let's do some different things on the string. So trying to type the string over. Let's do the string %s. Okay, and don't forget your quotes. %s new line, and just print my string. Okay, and then let's see how that goes. Syntax error on 8 or 9. Probably don't have this set up right in here. Oh, okay. Let's see. Should be my string for one thing. Let's do that. Okay, new line and string. Okay, that's probably from this. I probably need to set something up, but let's do it like that and see what we get now. Yeah, that I can set it up in here where I can actually do a splitter string. like that, but I don't have that set up right now. So let's go, and so it just prints the string. So let's do some more things to this string. Let's do some slices on it. Okay, take my string from 0 to 15, and these are from characters 0 to 15. Okay, and let's compile that. Okay, and this here, right here, is from 0 to 15. Alright, and let's do another one. I can take this new line off here because I'm adding that in anyway, so I don't need a double line. Okay, and let's FMT printf %s new line. Let's print it, and this is gonna do, if I leave out the 0 and just put a colon to 15, it's automatically going to start at 0 and print to that. So it's going to, this line, these two lines do the same thing. So let's compile it and see that. Okay, so those lines do the exact same thing. Okay, so now let me go from slice another area out, like in the middle. And this time I'm going to take my string from 15 to 28. And let's see how that works out. Okay, so see, we took another different section of the string. Okay, and now let's go from one section of the string to the end of the string, kind of how we went from the beginning to 15. So let's go from 15 to the end. And we do that by just leaving no endpoint. So let's save that and compile. Yep, so it went from 15 all the way to the end. So that's some operations, some slicing we can do within the string. Now let's do like a for loop. That's another basic thing. So let's do a basic for loop first. So for I, which is the like counter, and then L is going to be like the actual element, so gets the actual element. So for IL and range, my string. Okay, and this is how we declare a for loop, just like, almost like similar to a function. Okay, so what I want to do is fmt dot printf, and I want to print a decimal D and a character C equal a new line, and I is going to be the decimal, which is the counter, and L is going to be for the letter in the string. So let's see how that prints out. And before I do that, let's just clear it. Okay, you see, so the 0 character is D, and it goes character 49 is a space, so it just kind of enumerates every single character in the string. So that's one thing you can do. But say I don't care about the counter, you know, the index into the string, so I can just say put this underscore here, and that means, like, you know, not worried about that. And so what I want to do though is go here and change this and take this decimal D out, and so now we're just going to print the letter and not the index or the counter, because we didn't even give it a distinction, so that means we don't really care about it. So let's see what it prints this time. Let me clear this and compile, and it prints the same thing, but this time without the index of the letters. Okay, so now we can also do it the other way. I might not care about the actual letter, so I can put a underscore, get rid of that, and put the index back in. And so now I want to print the index, so I'm going to change this C for character to a D for decimal. Save that, compile, and now we have all the indices. Okay, and so that was kind of neat. So that's just some basic for loop stuff. Now there is also another way to do the for loops. I can say instead of this underscore, I can let's see, let me just so we can see this is like kind of like how you had the shortcut for the variable naming. You can have the shortcut for the for loop definition. Yeah, I forgot to take out the L. So now it should be right. And this does the same thing as the I, comma, underscore for the for loop definition. So this does the basically the same thing as for I underscore yeah, this is the same thing as that. You know, we've been doing the shortcut. You know, like we've been doing that, so now we don't have to do that. We can just do this also, and that's the same thing. And I'm gonna put another space there. So now we've done it like this, and we don't need the underscore, so this should compile. And there it is. Okay. So let me see, what else do I remember about the go loops? Oh, we can print the length of the string out. So let's do that. Print the length of the string. So we can get out of this for loop for now. Finish with it for a minute. Okay, but I still have my string, and let's print the length out. So it's really simple. FMT printf %d new line, and it's just the len function like it is in many languages. Control X, and let's compile it, and let's run it. And that's how many characters are in that string. Now and we can just print out, I can print out the string, and I already done that. So what's next? Okay, so now I'm going to go into functions, how to do a function, a basic function. So I'm going to import another package called OS. Okay, and actually, I'm not going to do functions yet. I'm going to do if statements. I totally forgot about the if statements. But I'm still going to use the OS call. And let me type it out, and then I'll try to explain it the best I know how. So the if is like, let's do if statement. So we'll just say if num bytes and error equal to fmt dot printf hello world, error not equal to nil, and put the closing brace. Okay, so where was I? Nil. Okay, so I'm gonna say os dot exit 1. Okay, and else, go ahead and put that in so I don't forget. Else fmt dot printf bytes percent d new line num bytes, and left the t out here, and let's see, does this compile, and then I'll explain it. Oh, forgot my closing. Okay, so in Go, an if statement can have one initialization statement before the condition, and the scope of the variables used in that initialization is limited to the code block of the defining statement. So and this initialization requires a semicolon after. So you see that I use a semicolon. I've never used a semicolon in this video yet. So this is the initialization, and it's saying that error is equal to format dot printf hello, and then world, change that. And you may say error is equal to that. Well, let's go to GoDoc over here. GoDoc FMT. GoDoc FMT dot printf. How did I do it? Oh no, it's GoDoc and then FMT and then printf, I think. Don't put the dot in. Yeah, so this is what printf, these are the parameters that it takes here, and this here is the return values that it sends. So it sends an integer and an error. So printf, it returns a number of bytes, that's what the n is, and any error that was encountered. So since no error was encountered when it did this printf, that's why we got the number of bytes is 13 there. So that's all that it is. It's a little confusing. So basically it's saying if you know, it's an error here, if the error is by default nil, but if it's an error, then this wouldn't be nil. So if that's the case, it would exit, and else it would print these bytes, and we'll know that it succeeded, and that's what happened. So that's why this if statement, at least to me at first, it looked a little confusing doing it like this, but it's because I can put this initialization right here. So one more thing I can do this initialization. Let me just comment that out. Okay, in fact I should have put the comment here. Okay, so let's do this another way now. Let's define some variables. Bar non-bytes, just like we had before, but this time we're explicitly declaring them. Bar error is of type error. So now let's do our if statement now. If n error equals fmt dot printf hello world new line Okay, so this is my initialization, and this should be num_bytes. Okay, and so if error is equal to nil, then os.exit 1. And if it doesn't exit, instead of putting else here, we can just, if it didn't exit, then we know to print this. Okay, it should compile. Yep. And it does the same thing. I probably type something. See, it's different here. The num_bytes is different because I left off the exclamation point, but it does the same thing as the previous example. Okay, so let's do one more thing, kind of like what we did with the for loop. Let's do this another way. Let's say if, and I don't care about the num_bytes, but I care about the error. So it's basically the same thing as before. So let's go in here and put os.exit 1, and this shouldn't do anything, but it should just run. So it just run. I didn't tell it to print anything else, but basically there was nothing to print because I got the error back and no num_bytes. I guess, let's see, I could print the error. Oh, yeah, I cannot print the error. I forgot. I can't print the error. I would have to do it because I could have printed the error up here because of how I defined it. Here, since I did the declaration, like when I said it before, like when I did the initialization here, before the condition, the scope of these variables is limited to this for loop. So, I mean, limited to this if statement. So that's why I couldn't print it. That's a good thing to remember. Okay, so moving on. What do I want to do next? Let's move on to switch statements. Okay, so let me do my string again. key. Okay, so now I have the string. Okay, and what I want to do is count the vowels. So we'll just make some variables here. These are just counters. And count the letter W, just for fun. Okay, so let's do this with a for loop. So we're going to say for. I don't care about the counter, I just care about the letter. And that equals gets its value from the range by string. Okay, and let's do the switch statement within the for. Let's switch on the letter that we're getting, and switch statement. Okay, and let's switch on case. The first case is the vowels A, E, I, O, U. That's the case statement. Okay, and so if it's any of these, this is how you do case statements. In Go, you don't really do case A and then another case, you know, E, and then another. You just put it all on this one line, so all the vowels go in this one case. So now we can say vowels plus equal 1. Okay, and then go case W, and that's going to be letter W plus equals 1, and then the default case is the default case is the consonant case, and it's going to be consonants plus equals 1. And so now let's do the FMT printf. And vowels %D consonants %D and W's %D. Now a new line, and vowels, consonants, letter W. See that I do this right. Let's clear, and oh yeah, I'm not using OS. You can take that out. Go tries to keep your programs very clean. Okay, so I have 15 vowels, 41 consonants, and 2 W's. So that's the case statement. Oh, and just in that's not totally correct, because this doesn't follow through unless I tell it to. So actually I should probably have 43 consonants. We'll see. Because once it hits a case, it does that case and it doesn't go. So I want the W's, since a W is a consonant too, I want it to fall through, and that's a key word here. Fall through is a key word. So let's compile it again and see the difference. Yes, 43 consonants, 2 W's. So you have to watch that with the case statements, because they don't automatically fall through, even if they what you have satisfies 2 case conditions. You have to specifically explicitly say fall through. Okay, so that was a case statement. I forgot to do, let's do some more for loop stuff. I've done a little for loop stuff. Let's go back and do some different ways of doing, or some extra stuff to do with for loops. So clear over here. Okay, so I'm gonna do like var counter int. So this is the first time I declared like an int explicitly with the int keyword. Okay, and counter equals 0. So now let's go to a for loop. For counter less than 10. This is a kind of for loop, you know, I'm used to seeing with the in this kind of format. So let's just print a statement here. Neptune is my favorite planet. That is true. So let's build it and run it. And you see, that was an infinite loop, because I forgot to do one important thing in the for loop. The way I have it set up, it's not self-incrementing, so I have to increment it myself. Counter plus equals 1. So let's build that again, and this time it should do it the correct number of times. Okay, so that's one way to do the for loop. Okay, turn on insert. Okay, let's do the for loop a little better way, so you don't have to keep up with the counter in the body of the loop. So let's say for counter, and we're doing an initialization for counter to 0, and then we're saying counter, and you see we're using semicolons here. This is kind of like a regular for statement. Counter less than 10, counter plus plus. So this is the normal type that you see in most languages, or at least most languages that I've done, I programmed in. And then we can do the same thing. Neptune is my favorite planet. And that's all we have to do. Let's compile it and run it. Does the same thing. And this way we initialize the counter, had the condition of the counter like we did before, and then actually also did the incrementing of the counter in the for loop declaration instead of in the body. Okay, so that's that's another thing to do with for loops. Let's do couple of more things with them. So for I, K, so we're declaring two counter type variables. Set both of those equal to 0. So I is equal to 0, set K equal to 1, semicolon. So we can set them to different values. They don't have to both have the same value. Then we say I is less than 12. That's the condition. And put a semicolon. So that's the condition. And then the next thing is K is going to be equal to, I is going to increment by 1. So I is equal to I plus 1, and K is K times 2. You have to keep up with these because it's easy to get thrown off with the equal signs, but because you're doing 2 assignments instead of 1. Okay, so let's do this again, and we're going to just print a number which is going to be K, that I'm going to print in front of the sentence. Okay, so if all works well, this will work. Let's clear it. Compile. And that's it. That's K multiplying itself. Okay, so that was one thing. Now that was one way to do it. That was another way to do a for loop. Here's yet another way. Let's do it with a bool variable. So we'll say var stop bool. So that's the bool variable. K K is equal to 0. And now let's do the loop. So for not stop, because the default value for a boolean is false, so for true, let me get my parentheses, my brackets right. Okay, so now I'm going to fmt dot printf Neptune is my favorite planet. Okay, and K, we're gonna plus equal 1. And here's the if in here too. If K is equal to 5, I'm going to set stop equal to true. And then it should stop. So let's see if I did this right. Let's clear this away. Okay, and there it is. Now, what else is there to do? Okay, now I can move on to functions. That was for loops for now, till I do something more interesting later on with them. So let's make a function. So I'm gonna, here in function main, I'm gonna call a function that I make in this hello.go program. But before I make it, I'm just gonna kind of call it here. I'm gonna call it printer and call Neptune is, call it with Neptune is my favorite planet. Okay. Now I'm gonna go up here and make the function. So it's just like I make the function main basically. So function printer, it takes a message of type string, and it's just gonna print the string out in a formatted way. So we're just gonna call, that's gonna be a string. It takes a string, and I need to put that, okay, and it's gonna print the message. Okay, now let's run that and see, does it work? There it is. It works. Okay, so that's a basic function. Let's do a little more with that. So let's break this up and say Neptune is, that's one string, and then this is the second string right here, and also 4. Print the number 4. So not the number 4. It's not going to print 4. That's going to have many times it's going to repeat. So let's go to the function. So this function now is going to take a message 1, a message 2, both of type string. So since these are both string, I can just say message, comma, message 2, and then put string after them because both of those are strings. Okay, and then a repeat is the variable name and it's of type int. Okay, so let's put a for loop in here and say for repeat greater than 0. Okay, and all of this is going to be in that function. So we're going to print message, the first message, and we're going to Just like that, print the next message. Message 2. And we're going to decrement repeat. Now this should work. And there it is. So what else can we do with functions? Okay, so now we've done that. So now let's kind of do an error. Say that we're going to make the function return an error. So if this function returns an error, and let me just take this back to its original form. Okay, Neptune is my favorite planet, and Neptune is, let me check on something. Okay, Neptune is my favorite planet, and so I'm going to say print error here. So we want to, this is going to be a print error that it returns. So let's go make the function so that it reflects what I'm trying to do. So this function is going to take a message of type string, and it's going to return an error. I haven't named the error, it's just going to be an error. Okay, and so here in the, forgot to take that out. Here in the function body, okay, for the I'm calling format, so this error that it's going to return is actually going to be from the format.printf. So I don't care about the num-bytes that it's going to receive. So here's I want the error. I'm going to set that equal to fmt.printf. Set s new line message. Okay, and have it return that error. And let's go here, and that should be it. It's nothing really to print out since it's not going to be an error, but oh, so they're telling me that print error is not used. Well, it is used. Let me make sure. Let's say 1 minute. Okay, so let me go ahead. Excuse me. and do this real quick. So basically, let's see, how do you, let me see, I think I can do it like this, print line, something like this. I get confused sometimes. Let's see. Yeah, that'll work. Yay, got it. Okay, yeah, you can't print the error with printf. You have to print it with print line. It's another way, like recover or something. I forget how that goes. But anyway, so now it's used, and so now, yeah, that's the thing. You have to use almost everything you do in Go. It doesn't allow you to kind of have messy code. You have to kind of use everything you put in, so it's really tight. So that's one thing to do. So we got an error back, and we printed that. Okay. So let's continue with the errors. So let's redo this. And I'm going to take this out. Okay, and we want a function again. This time I want the function to have the string message, and then have like a string returns a string, and it returns error. So for this to work, let's do this. Let's say message plus equals, and append the new line character, and here we can just say printf message, and we can leave this the same because we're not worried about the non-bytes. We do want the error message, and we can return message and error. So now I need to receive a print error and a returned message. Okay, and if print error is equal to nil, we're going to print the message, and we're going to use this Q, and that's going to show the whole message, including like the new line character that we appended to it. So, and return message. So let's try this out. Okay, I put print TT instead of print F. Okay. Oh, I didn't save it. Okay, so see, this here's the message printed from the function, and then this is the return. So this is the message exactly as it was sent. We didn't send it with a new line or anything. This is the new line appended to the message. So that's what that %Q does. So that's just another way to print, you know, instead of the %S. Okay. So now I'm going to go to something else, and I'm just going to type this function out, and then I'm going to explain it. Let me just get rid of all of this and just go back to our basic. And I'm going to have 3 strings in printer function this time. It's going to take 3 strings. So it's going to take Neptune is my favorite planet. Okay, and it's also going to take hello, how are you? And gender. And today is a good day. Okay, so it's going to take those 3 strings. Okay, so now I need to go up here and change my function. And the function is going to take, instead of 1 messages, it's going to take messages. And I'm going to denote that it can take any number of messages by doing that ... string. Now you can do this on other variable types, like if it was ints, like ... int. But here I'm doing strings. So, and how I'm going to process this is I'm going to take all of this out. Okay, and we're going to process this variable number of strings with a for loop. I don't care about the counter, I just care about the messages. So the messages are going to get the values from a range of messages. Okay, and for each message, we're just gonna call format. We're gonna printf %S new line message. I'm gonna print each of the messages. Okay, and let's clear this, and I'm just gonna run it, and then I'm gonna go over. Okay, so it printed each one of those messages. Now I could have sent it 1 messages or 20 messages, any number of messages. Because this is what you call a variadic functions, and they can be called with any number of trailing arguments. Now I couldn't do like, I couldn't have like message and then have like my ints. That wouldn't work. I only get I believe only get 1 of those per function. So I'm used to here, so I can't have another variable in here. I can't have my ints in here that takes, you know, any number of arguments also. So that was just kind of a neat thing to show. Okay, so we can keep going with the variadic function. So I could have this, but I can only use it once. So let's do something else. Let's send a format string, and so it's a string that denotes the format, like, you know, this is %S here, that's a format, that's a string. So telling it to print it in string form. So let's do something a little different. Okay, we're going to keep the for loop and everything. And what I want to do is printf, and instead of having this hard coded here, I'm going to print it in whatever format is sent to me. So now I needed to prefix. So here, so I need to send a string, a format string. So the format I'm going to send is %x new line. And what this is just print it in hexadecimal, something like that. I think that's hexadecimal. So let's try this out and see what we get. So see, it's reprinted like in hex, so kind of like an encoding. So that's mainly all I have for functions right now. So let's get rid of this function, and I forgot to go over one thing. And so let's just get back to basic main program where we have fmt the printf, and I'm just going to print message and answer. And the thing I'm going to do here is make some constants, and this is how you make it, kind of like you do the imports. That's what the syntax kind of looks like. And we can do a message. So these constants are going to be like global, so I can use them anywhere in this program. Do I have %d because I'm going to use a decimal. I mean, yeah, decimal number. And the answer is going to be 2. So let's just do that. How many laptops do I have? 2. So that's it. That's all I have for now with Go. I'm on the path to trying to learn this language, and so I'm just going to keep on, and I'll be back when I learn some more stuff to share that.